The water turns milky white. Fish begin to surface, disoriented, gasping. Within minutes, dozens float belly up along the riverbank. To an outsider, this looks like ecological disaster. To the Sakuddei people of Indonesia's Mentawai Islands, it's Tuesday. For thousands of years, the Sakuddei have practiced a fishing technique that seems to contradict everything we know about sustainable resource management. They poison their rivers. Deliberately. Regularly. And yet, the rivers thrive. This isn't recklessness. It's science refined over millennia, a fishing method so precisely calibrated that it harvests protein without depleting fish populations or damaging the aquatic ecosystem. Today, we're diving into one of indigenous knowledge's most misunderstood practices, plant-based fish poisoning. How do you stun fish without killing the river? What plants hold this power? And what can modern conservation learn from a technique that predates written history? The Sakuddei call it tuba. Scientists know it as Derris elliptica, a woody vine that climbs through the Mentawai rainforest like a green serpent. Its roots contain rotenone, a natural compound that interferes with cellular respiration in fish. But here's what makes this remarkable: rotenone is species selective and biodegradable. When Sakuddei fishers crush tuba roots and release them into river pools, the compound targets fish gills specifically. It prevents oxygen absorption, causing temporary paralysis. Fish float to the surface, unable to swim but still breathing. The effect is reversible for many species if they're swept downstream into clean water. Mammals, birds, and insects? Largely unaffected. Rotenone breaks down rapidly in sunlight and moving water, within hours, sometimes faster. The river flushes itself clean. Tomorrow, fish will swim through the same pool as if nothing happened. This isn't ancient people stumbling onto a convenient plant. This is sophisticated environmental chemistry, passed down through oral tradition, tested and refined across hundreds of generations. But choosing the right plant is only the beginning. The Sakuddei don't poison randomly. Every fishing expedition follows rules as strict as any modern fisheries regulation, rules that determine when, where, and how much poison enters the water. First rule: seasonal timing. The Sakuddei avoid poisoning during spawning seasons. They've observed fish behavior for centuries and know when populations are most vulnerable. During breeding months, the tuba stays in the forest. Second rule: location rotation. The same river section is never poisoned twice in quick succession. Sakuddei communities maintain mental maps of fishing zones, rotating through them to allow full recovery. Some areas might rest for months or even years. Third rule: scale control. Only enough poison for immediate need. There's no storage, no surplus harvest. You prepare tuba roots for the fish you can eat within days. Overfishing isn't just wasteful, it's culturally shameful. These aren't written laws. They're cultural knowledge embedded in stories, songs, and apprenticeship. Young Sakuddei learn poison fishing the same way they learn language, through immersion, observation, and correction by elders who've spent lifetimes reading the river's moods. Let's talk about what happens at the molecular level, because this is where indigenous practice and modern science converge in surprising ways. Rotenone blocks complex I in the mitochondrial electron transport chain. Translation: it stops cells from using oxygen to produce energy. For fish, whose entire oxygen intake depends on water flowing over their gills, this creates rapid paralysis. But, and this is crucial, rotenone degrades quickly through photolysis and microbial breakdown. Half-life in river water? As little as 1 to 3 days under tropical conditions with strong sunlight. The Mentawai rivers have fast currents and abundant UV exposure. Perfect conditions for rapid detoxification. Compare this to synthetic pesticides used in modern agriculture. Compounds that persist for months, bioaccumulate in tissue, and travel downstream to poison entire watersheds. The Sakuddei method is chemically elegant, targeted, temporary, traceless. Modern fisheries biologists who've studied this practice note something remarkable. Poisoned river sections show no long-term decline in fish populations or biodiversity. The ecosystem rebounds completely. How? Here's where the Sakuddei demonstrate understanding that goes beyond the plant itself. They've grasped the entire ecological web. First, the poison is selective by size and species. Rotenone affects fish differently based on gill surface area and metabolic rate. Larger, older fish are more resistant. Juveniles in shallow nursery areas, often separated from main fishing pools, remain largely protected. Second, the Sakuddei poison small, isolated pools, not entire river systems. They build temporary dams using rocks and logs, creating controlled fishing zones. After harvest, they dismantle the dam. Fresh water flushes the area within hours. Third, and this is the insight that stuns ecologists, the Sakuddei understand refuge populations. They know fish survive upstream, downstream, and in connecting tributaries. A single poisoning event never impacts the entire breeding population. Recolonization happens naturally within weeks. Research from tropical ecology labs has confirmed what the Sakuddei have known empirically. Small-scale, rotational poison fishing has negligible impact on fish population genetics or community structure. The river heals itself faster than exploitation can damage it. But there's a critical variable that makes all this work. Population density. That's the variable modern conservation often ignores when evaluating indigenous practices. The Sakuddei number fewer than 10,000 people across the Mentawai Islands. Their fishing pressure is fundamentally different from industrial-scale extraction. A community of 50 people poisoning a river pool twice a year? Sustainable. 1,000 people doing it weekly? Collapse. This is where cultural practice intersects with social structure. Sakuddei fishing isn't individual entrepreneurship. It's communal activity governed by consensus and reputation. Overharvest brings social consequences, loss of status, exclusion from cooperative ventures, shame. In societies where your survival depends on your neighbor's goodwill, destroying shared resources is social suicide. The river isn't property to exploit, it's a relative to respect. This animistic worldview, where natural features possess spiritual agency, creates practical conservation outcomes. The Sakuddei aren't noble savages living in harmony through innate virtue. They're practical people who've learned, sometimes through catastrophic failure, what practices allow long-term survival. Oral histories preserve stories of fish disappearances, famines caused by overfishing, migrations forced by resource collapse. Their current practices are the survivors, methods that worked, refined by trial and error across countless generations. But here's the uncomfortable reality: this delicate balance is collapsing. Not because the Sakuddei are abandoning their practices. Because the world around them is changing faster than adaptation can keep pace. Commercial logging fragments the rainforest, disrupting the watersheds that keep rivers clean and fish populations connected. Palm oil plantations introduce agricultural runoff, actual persistent poisons that make traditional tuba fishing look like homeopathy by comparison. Indonesian government policies, designed to protect fisheries from destructive practices, sometimes criminalize indigenous methods without understanding their nuance. Poison fishing gets banned alongside dynamite fishing, even though one is sustainable and one is catastrophic. And then there's the subtler threat: cultural dilution. Younger Sakuddei grow up with access to motorboats, nylon nets, and smartphones. Why spend hours preparing tuba roots when you can use a gill net? Why learn the seasonal calendar when you can just fish whenever? The knowledge isn't passed through textbooks. When elders die without teaching apprentices the location of tuba groves, the timing of spawning seasons, the songs that encode fishing territory boundaries, that knowledge disappears. Permanently. One elder told an anthropologist, "My grandchildren can name every character in their video games. But they can't tell which vine is tuba and which will make them sick. What happens when I'm gone?" So what can this ancient fishing method teach our modern, overfished, plastic-choked world? First, sophistication exists outside laboratories. Indigenous practices aren't primitive versions of science, they're parallel systems of knowledge tested across time frames industrial society can't match. Second, sustainability isn't about avoiding impact, it's about scaling impact to recovery capacity. The question isn't, does this harm the ecosystem? Everything we do has impact. The question is, can the ecosystem recover faster than we exploit it? Third, effective conservation requires cultural context. You can't transplant techniques without transplanting the social structures, population densities, and worldviews that make them work. Tuba fishing is sustainable for the Sakuddei not just because of the plant's chemistry, but because of who the Sakuddei are. And fourth, the most sustainable technologies are often the invisible ones, encoded in language, ritual, taboo, and story rather than written in manuals or enforced by regulation. The Sakuddei poison their rivers with surgical precision, harvesting protein without destroying their future. They've done it for thousands of years. They could keep doing it for thousands more, if we let them. But preservation isn't about freezing cultures in amber or idealizing the past. It's about recognizing that some solutions to modern problems already exist, practiced daily by people we've spent centuries dismissing as backward. Maybe the question isn't, how do we teach the world to think like the Sakuddei? Maybe it's, how do we create space for the Sakuddei to keep being Sakuddei? Sometimes the most advanced technology is a root, a river, and the wisdom to know the difference between enough and too much.